Hello YouTubians. In this video I will try to answer what back EMF is. I will not pretend to be an expert on the subject, quite the contrary, I'm just now starting to grasp what it really is. But because I had so much trouble finding info about it, I have decided to share what I know with you. To further your knowledge, I will recommend to watch a great DVD by Peter Lindman called Electric Motor Secrets. Okay, so EMF stands for electromotive force, and that's a fancy lingo for voltage. Again, EMF equals volts. Back EMF is back voltage. So what is it? We will pretend that this looks like DC motors. In scenario 1, we will spin the shaft ourselves without a power supply. What will happen is the motor will produce electricity. Why? Because inside the motor you have coils of wire rotating around a permanent magnet. And when you have a setup as such, electricity is produced. We call that electricity Y. In scenario 2, we hook up the motor to a DC power supply. And as a result, the shaft will start spinning. Why? Because that's what motors do. We'll call that electricity X. But, as we saw in scenario 1, when we have a shaft that's spinning, it generates Y. To understand what happens next, we've got Y here, we've got X going there. To understand what happens next, just imagine a car and a truck coming towards each other on a one-way street. It's not going to be pretty. Y will be completely cancelled by X because X is always higher. So if, for example, X is 12 volts and Y is 9 volts, the working voltage on a motor will only be 3 volts. Y being the back EMF. The reason our conventional motors consume more when loaded is because when you put a load on it, you slow the motor down. When the motor slows down, it generates less electricity Y, but X does not change. Let's relate it to our example. We put a load on the motor and slow it down. Then Y goes down to, let's say, 6 volts. Whilst X remains at 12 volts because the power supply is independent of the motor. So back to our equation. We have X is 12 volts minus Y is 6 volts. You have 6 volts left. Now the working voltage is 6 volts, which is higher than 3 volts, therefore the motor consumes more. So how do we deal with this annoying Y? Well, in Bedini's case, he double winds his coil. Instead of one wire, he puts 2, tightly wound together. Because you see, when you have a coil with an iron center, and you pulse a square wave into it, once again, X, the iron concentrates the magnetic flux at the poles, 1, 2, to perform work for us. And when that magnetism collapses, the energy wants to go back into the wire in the opposite direction. Once again, Y. And we are back to our car, truck, one-way story. So by providing another set of wires, Bedini allows Y to escape another way. Car, truck, two-way street, not so much of a problem anymore. See, electricity, much like people, is always looking for the easy way out. Alright guys, that's the setup. I just wanted to illustrate how the double wound coil works. There's 4 wires, as you can see. It's the primary connected to the battery and the secondary connected to our meter. I just wanted to show when I pulse X where Y goes out and how it looks like. First I'll convince you that this is an electromagnet. Once I pulse the... Okay, hopefully you're convinced. And now we'll switch on the meter and we'll see how it behaves. So once again I pulse electricity X through the switch from the battery, and the multimeter will accept the Y electricity coming out of the secondary wire. We'll press in, out. As you can see, when I press in, the meter goes negative. When I depress the button, the meter goes positive. And I think that is our answer why my Bedini replication spits out 2728 volts AC. Once again, let me try that. In, minus, out, positive. In, negative, out, plus. So Bedini goes on, off, and very quickly, and therefore generates alternating current. Now why I cannot rectify it fully with the bridge rectifier, I do not know. He recovers Y with a secondary battery, and voila! You have a motor that uses magnetism, which is a natural force to generate power, much like we use the wind. It breaks the laws of physics as much as a solar panel. It doesn't. Alright, that's it for today, folks. I hope that was helpful to you. Let me plug the DVD one more time. Electric Motor Secrets by Peter Lindemann. And if you want to be really smart, watch Energy from the Vacuum 1 and 2 by John Bedini and Tom Braden. Tom is a physics professor and in my eyes a guru when it comes to free energy and thinking outside the box. Okay, love you guys, stay tuned and bye for now.